Hi everyone. Okay, so the agenda of today's video is very simple, just three things. Show how I want to show you how to run LLM locally. So I'm getting these questions, and these are the most relevant questions when we are talking about Gen AI and all those things that if I am connecting with Hugging Face or OpenAI or Microsoft Azure, and those are not enterprise version, and so where is my data? Who is processing my data, who can see my data, and my data is very important because it contains personal identification information or something related to that. So means I will be more safe if I can run an LLM on my local server. Second thing is, if you are running a LLM locally, and obviously, I want it to connect to a ServiceNow system or instance, just to see that because I want to leverage it with my workflows, right? Like suppose OpenAI or Llama uh, LLM is running on my local server. I want to connect it with ServiceNow so that I can leverage its functionalities and get the intended output that I want without sending my data out of this out of my network. And the third is means what type of LLM can run on my machine. So you will understand each of these questions while we go through my video. Now, first thing, the most important thing is I want to show you how LLM can run locally. So to run an LLM locally, I'm going to use a UI which is developed on this library, and I wanted to show the backend that uh, means this Llama CPP is an open source library, and I wanted to show you because you should understand what is really happening and how it is running. So Llama CPP is basically a C++ library, and what it does in a very crux way that it provides, so it encapsulates various methods and functionalities of running an LLM. So like how it should, whether it should use a GPU or RAM, or if we want to create a server of that local server for that service, then how can we do that? So all those things can be done with the help of Llama CPP very easily. So this library encapsulates most of the functionalities of LLM. So we don't have to even worry about that. But even running this is requires a little technical expertise. Means like in-depth technical expertise, because you have to, there is no UI for this. You have to have like Brew to install this. Then there are commands present on as like if you want to create a HTTP server for your service, then you will have to like port and all those things. So there are commands that you have to use. Okay. So now to even encapsulate these informations, there is another UI called LM Studio. LM Studio is amazing, and it's the minimal effort. I think anybody can run, if they have a hardware, anybody can run an LLM locally on their system. What they have to do, so if you just have to search for LM Studio, that's it. It's not LLM Studio, it's LM Studio. Okay. Once you search for it, there are in the main page, there are three options, whether download it for Apple or Windows or Linux. Okay. Now, if you have downloaded, so mine is Apple M2. So I just downloaded it. And here you can see uh, the DMZ file is present over here. I've already downloaded it, and I just ran it, install it. It will immediately get installed. And once it is installed, it will be present in your applications. Go to your applications. So once it gets downloaded, you will see a page like this. Okay, just you will end up on home, and this will be the page. Now here what you are seeing over here are different large languages model, which are like available by default from LM Studio. So Llama 3, 8 billion parameters. So there is a 170 billion parameters as well. Parameters are the, so like we can say, the more the parameters, more heavier is the model. So it's better to check for lower parameter model first, to make sure that if you are not aware that what is the hardware configuration of your system, it's better to go from lower ones to middle, to above. Because if you go directly for 70B and means, so right now it's 7 billion parameters, and it provides a little bit information, like it requires 8 GB plus RAM, and my system has only 8 GB RAM. So obviously it is not good for my system. But if you don't even know what your system has, I would say start with something very small, like 2 GB. But if you want to run a big one, let's just, means I did it. So I just downloaded it. You just have to click on this, nothing else. You will see a progress bar over here. It will download your model. Now, once you have downloaded it, now I want to test it. So let's just test. Let me so first you have to select your model. So I have 2 models downloaded already. Once you download, that many models will come over here. The Llama one, I want to test that. Let's see. So can you tell me us in 2 lines? Okay. Let's see. Now, once it is running, the best thing about this is, if you right now, I cannot uh, do, because I am recording the video on Zoom. But if you'll remove, means cut off your internet, this will still be running, because this is all local. It is using your hardware. The model is also downloaded in your system. Tokenizer related to that model is also present. What embeddings on which the train data, everything is in your system. So there is no connection to internet. If you are sending any sensitive data over here, it is not going anywhere else. It is everything is running locally on your system for free. That means this was it. So our first point has been covered. Now, and the most important thing when you are running these things and this LLM Studio, LM Studio, is you can understand, so out of 8 GB RAM, how much I'm using and what CPU percentage I'm using. And so you see, these models are generational models. So they create they generate texts, right? My system is like what, 8 GB RAM, and yeah, it is Apple Mac M2, but it means there is no GPU. So you can see how much it is struggling. Means it is taking ample amount of time because it is such a big model. In adding token one by one after each iteration. And I will show you even like this after, means once we'll start with a server. So you see how it is taking. So it is giving a good answer. It's a lightweight, high performance C++ framework for building scalable and concurrent network applications. So basically, if you're running a server related to this application, and multiple systems are connected to that server, they can do concurrent operations uh, using that server. And I will show you how we should do that. So I will just stop the generation process, because obviously we understood that this is running fine, but it is taking a lot of time. Let's just now, the prompt, the dialogue box that came was related to the system prompt. So you understand how the system prompts comes in? Like system prompt is nothing but uh, an instruction to the model, to the large language model, how to behave. Like you are a helpful pilot. Okay. Instead of assistant, I want to say that you are a helpful pilot, and I want it to do the same task. But because now you have to focus on this part that this is a small model, so it is only 3 billion parameters, and on the disk it is taking 2 GB RAM. Okay, so let's see. Not the RAM, just taking 2 GB on the hard disk. RAM is over here. Let's so I want to simply run it. Now it is running 5.3 from Microsoft instead of Llama. And you see how quick you can see the difference. Uh, like now when it is generating the text, it is far faster than the one when we were doing it with Llama. And the term Llama could refer to new brand, new projects, and unique names. Like, okay, so it may not have that information, what is Llama CPP is, but it is still is good. So it was able to understand what I'm trying to say. It is still is good. And I got the answers even pretty quickly, right? So now what I want to do is I want to use this in my Visual Studio. So for that, what I should do is, uh, so here you can see there are different options. So there's a playground. You can play with it. What is playground? Is like you can play. It's a multi-model system where you can provide a custom instruction how it should behave and all those things. And then first you have to select the model which you want, and then like play with it as in uh, like how means do prompt engineering and make it run that, okay, this is how I want it to behave when I'm answering questions. Okay, now so and here you can also see that what is the RAM uses. So out of what you have already. But what I'm interested interested in is the server. So here you can provide the server port where you want your server to be running, and then other information is also present. I want to see the logs over here, and prompt formatting should also be there. Now, and if you want to use it as a Python chatbot, you just simply have to do this. So you just copy the code. I think I have already copied it. And yeah, so my server is running on localhost 1234, which is the port that is available over here. And uh, an API key, it doesn't matter. Then it is importing OpenAI format. So here we are not using OpenAI like model to connect with. If we are just using OpenAI format, how means these role, how you will send the message. Okay, and all those things. Even if you have provided the model over here, it will only, so here, so whatever model that you have provided over here is the model which is running on this server. So suppose if I will change it to Llama, then it will be the Llama which is running over there. But because I'm using because Llama is like really slow on my system, I want to use 5.3. Okay, so whatever information you have provided over here doesn't even matter actually. So and you can even test it that Llama is really slow for me, right? But if I will just make it 9, temperature, don't want it to hallucinate, and let's just see. And immediately it started running, and you can see it is the 5.3 model. See, even whatever is present, and it is adding tokens each one line by line. It is very fast than Llama. And you can also see what number of token that is being added. So there are total now 71 or 81 tokens. And let's just wait for it to get completed. Okay. And let's just, it's a very, so it is going very detailed introduction, which is fine. So at the end, you found that, okay, so the greeting, I am an artificial intelligence designed to explore and discuss philosophies, concept across multitude disciplines, and my purpose is to blah, blah, blah. Now, sorry, not terminal, Visual Code Studio. And here, if I'll check the information, then you see this is the information I got. Let's just go through it. So here you have seen that the assistant has provided this information that the same thing, greeting, I'm an artificial intelligence. Once I asked, always answer in philosophy, and user said, introduce yourself, who are you? Then the assistant said these many things. So it can do function calls and tool calls, everything. But we just wanted to. So now again, everything is running locally, everything is free. And you saw that how my system with 8 GB RAM was able to perform a really good interaction with an LLM. Okay, your data is totally safe, is not going anywhere else. Now, we have a service which is running on localhost 1234 v1. So there are a couple of different things that you see over here, like you can use an assistant API, Vision API, embeddings. So for Vision API, you may use, so 5.3 may not be a very good model, but you can use stability, diffusion models, all those things. Okay, so moving to the next agenda of our video. So the next agenda of our video was, let's just go back. Where is it? So it's a Safari, right? Okay, here. So the next agenda of our video was, so I showed you how to run LLM locally, and even showed you which one, how you can even understand from from your LLM Studio that which LLM should be better for your machine to run. Next is how to connect a ServiceNow instance to a LLM. Okay, so I'm on a Mac, but let me show you the architecture. So to connect a ServiceNow instance to to a server which is to a service which is running locally. So this is my Mac, and there's a service which is running on my local host 1234 port number. Okay, and that has been initiated by LM Studio. Backend is Llama CPP. Now, if I want to connect my service now to this local host, the simplest way is I will create a REST message, and um, first I will install a mid server on this server. Okay, then I can access the service which is running on this mid server or via REST message. So the HTTP method can be used to connect to this and get the information. So I'll just show you a little. So if I have an endpoint, so this is a chat completion endpoint. You can have any type of endpoint, which is running on localhost 1234. And so the mid server, which is installed and on this machine. So the traffic, if my mid server is installed in machine, I can simply now run this endpoint to get information. Like means you can send a prompt and get a result from it. And why? So I won't be able to show you like in means practically, because I cannot install mid server on Mac, and I don't have Windows device. So apologies for that, but This is the way if you have a Windows device and a good configuration on your Windows machine, like 16 GB RAM or 32 GB RAM, I would say start with a 5 model, Microsoft 5 model on your, so install a LLM Studio and get a 5 model and run it locally, create a local server, install a mid server on your Windows machine, then create a REST message as I've shown over here, simple a REST message and endpoint, and then connect to, so if you want, I will give you the code. I mean, in the LM Studio, you can also get the code for connecting. Yeah, so the code. So here is the endpoint, right? This is the content type. You have to provide these prompts. So the model is this, message this, these things will be in body. So temperature, max token, stream. And once you will run with these commands, you will get the response from your local server. So now your ServiceNow instance is connected to your local machine, and which is running a service, an LLM as a service. Okay. So that was the second part. And the third part, I think with the help, means if you have to go deep into understanding what else we can run, how fast we can run, I would say, and one thing I didn't show, so any model which is present on Hugging Face, there is an option over here, search. So you search directly, and then it will show that full GPU offload possible, likely too large for this machine. So this is a instruct model, but it's 7 GB. And this is an instruct model, but this is 2 GB. So it provides you a compatibility guess to your machine. So your machine information is already present in the system, and it provides you that information. Now suppose if I'll go for Mistral, it will it will provide you all this information that which model you can run in fast enough, but which model will struggle and which model will be too large for you to handle. Okay, so you can still run it because we were running Llama 7B, but it will clearly you can clearly understand from these guesses, compatibility guesses from LM Studio, that which one is better, which one is not. Okay. I hope this video was beneficial for you. So thank you. That is